So, Jai Hind everyone. I am Nikita Jaiswal from Civil Engineering Department, and now I'll be recovering topic types of similarities part 2. So, now we have introduced what is the concept of similarity, what is model investigations, and what kind of similarity or dimensionless which are based on dimensionless numbers. So, we have studied how we can derive that particular dimensionless numbers and what are their significance. So, we have gone through model investigations, type of similarities. So, type of similarities, as we know very well now, that there are three kind of similarities: geometric, kinematic and dynamic. And also we have gone through various models. Here you can see in the screen that Reynolds model law, Froude model law, and we know very well how we can formulate all these particular laws. Okay, and we have gone through the other one, Weber model. So, now we are going to talk about how we can solve any particular problem on the basis of the situation required and on the basis of different model laws. So, we have gone through 5 model laws. Now, we'll solve and we'll see how we can solve any numerical on that particular model law. Here the question states, a pipe of diameter 1.5 meter is required to transport an oil of specific gravity 0.90 and a viscosity 10 to the power minus 2 poise at a rate 3000 liter per second. So, here you can see that a pipe with a diameter is given. Okay, that pipe is carrying a particular kind of oil with specific gravity 0.90 is also given, and the viscosity of that oil is also given, and the discharge is 3000 liter per second, or you can say 3 meter cube per second. Now, what question again states that tests were conducted on a 15 centimeter diameter pipe. The question is asking for test conducting diameter, that is 15 centimeter. That means that particular question is telling about the dimension of model. Okay. Here the model of this pipe is 15 centimeter diameter pipe. Now that particular model is using water, okay, as a flowing fluid at 20 degree centigrade. Find the velocity and rate of flow in the model. Viscosity of water at 20 degree centigrade is given as 0.01 poise. Okay. Now, you need to write what are the parameters that are given. So, here you can see the diameter of prototype is given. Viscosity of fluid in the particular model is also given, 3 multiplied by 10 to the power minus 2 poise. And here discharge for prototype is 3 meter cube per second. Also, the specific gravity of oil is also given as 0.9. Now, density of oil, how you can formulate density of oil? You just multiply 1000 to specific gravity of particular fluid. So, here that will be your 0.9 multiplied by 1000. So, that will be equal to 900 kg per meter cube. Now, just talk about model dimensions. Here diameter of model is given as 15 centimeter, or you can say 0.15 meter. Okay. Viscosity of water is simply given as 0.01 poise, or you can write it as 10 to the power minus 2 poise. Now, density of water is what? 1000 kg per meter cube, as we know very well. Now, because this is a type of pipe flow, so the dynamic similarity will be obtained if Reynolds number in the model and the prototype are equal. So, we need to equate Reynolds number in both for model and prototype. Okay. So, we need to apply an equation which states formula, okay, of Reynolds number. Here you can see that formula for Reynolds number is rho v d by mu. Okay, just equate for model and prototype. So, here you can see you can get Vm by Vp equal to rho p by rho m, and dp by dm and nu m by nu p. You know all the other dimensions, all the other parameters. Here rho p, that means mass density of prototype. Here rho m is, that means mass density of model. D representing diameters, nu representing viscosity. All the parameters are actually given in that particular question also. So just put all the given parameters in particular formula. What you will going to get as Vm by Vp. Okay, Vm by Vp as 3. Okay, now because we know the discharge flowing in particular prototype and also the diameter of prototype, so we can get Vp. So Vp will be what? Your 3 divided by area, or area you can formulate as pi by 4 1.5 square. So just you need to calculate formula for Vp and you will get the value for Vp as 1.697 meter per second. Okay, and because now you know Vp, okay, and just some seconds before we have formulated Vm by Vp as 3. Now we know the value for Vp. So Vm will be what? 3 multiplied by Vp, or 3 multiplied by Vp we have just formulated as 1.697. So this will be equal to 5.091 meter per second. Okay, 5.091 meter per second. Now the question was asking for discharge also, discharge flowing through model. So how you can calculate discharge? It's simple, just multiply area to particular velocity. So am multiplied by Vm, that will be equal to area multiplied by Vm, that means pi by 4.15 square multiplied by 5.091 meter cube per second. So finally you will get rate of flow through model, that will be equal to 89.9 liters per second. So the situation was simple. We have just applied Reynolds model law in this particular question. Now the problem, next problem. So we need to understand, we need to again analyze the situation, how we are going to apply that particular model law. Now question states, this is example of problem for 12.16 of your book R.K. Bansal. Okay. The question is saying water is flowing through a pipe of diameter 30 centimeter at a velocity of 4 meter per second. Now the diameter for pipe is given, velocity is given. Find the velocity of oil flowing in another pipe of diameter 10 centimeter. Okay, the question is somehow replicating the same situation of prototype and model, and again the question states that if the condition of dynamic similarity is satisfied between the two pipes. The question already have told you that the dynamic similarity exists between the two pipes. Okay, the same situation arises of model and prototype also in here in this case. So the viscosity of water and the oil is given as 0.01 poise. Okay, 0.01 poise and 0.025 poise respectively. Okay. Now the specific gravity is also given. Specific gravity of oil is also given as 0.8. Whenever we are going to find mass density or rho value for a particular oil, what we are going to do is 0.8 multiplied by 1000. Okay. Now the two pipes having different liquids, so we are just naming as pipe number 1 as just pipe 1, okay, and another pipe as pipe 2. So in the first pipe the liquid was actually water and the diameter was 30 centimeter, velocity was 4 meter cube per 4 meter per second. Viscosity, here you can see how we are going to convert, how we convert poise to SI units. So we just divide by 10. Okay, the density is also we know very well of water. Now come to pipe number 2, where the liquid was oil, the diameter was 10 centimeter. The question was asking for velocity of flow. Okay. How we are going to calculate it? See, all the parameters in both the pipes are given, just we need to calculate the velocity in pipe number 2. nu2 is also given, rho2 is also given. Rho2 is given in the form of specific gravity. We need to multiply it by 1000. You will get the density in pipe number 2. Okay, since the question has already told you that the pipes are dynamically similar, so Reynolds number for both the pipes should be same. Okay, so you need to apply Reynolds numbers model law in both the pipes. Okay, you create Reynolds number for pipe number 1 and pipe number 2 and just equate it. So here you can see the equations for Reynolds number have been equated, and now because the question was asking for velocity at pipe number 2, so we have just placed the other terms on the RHS side. Okay, now rho 1 was given, rho 2 is now known to you is 800, d1 is known to you, d2 is known to you, nu1 and nu2 is also known to you, and v1 is given in this particular question as 4 meter per second. Now just calculate all the other values. What you are going to get as v2 as 37.5 meter per second. This will be your final answer for velocity in pipe number 2. Okay, so now the next question states the ratio of lengths of a submarine and its model is 30:1. Okay, in this particular question the question is somewhat different. Again they are saying about ratio of dimensions. Okay, so question is saying ratio of lengths of a submarine and its model is 30:1. Okay, submarine, that means prototype, and model 30:1. So you can write it as LP by LM equal to 30. Okay, the speed of the submarine is 10 meter per second. Submarine is 10 meter per second. The model is to be tested in a wind tunnel. Okay, they have told you what kind of model arrangement is there that should be tested under a wind tunnel. Okay, find the speed of air in wind tunnel. Find the speed in wind tunnel. That means they are asking for value for Vm. Okay, also determine the ratio of the drag between model and its prototype. So we need to know what is drag in between, what is drag, what is resistance. We are going to discuss it. Take the value of kinematic viscosity for seawater and air as 0.012 Stokes and 0.016 Stokes respectively. The density for seawater and air is given as 1030 kg per meter cube and 1.24 kg per meter cube respectively. So in this particular question where they are asking for ratio of drag resistance between model and prototype, and also the other question. Okay, so how we are going to see what are the situations. See, this is a question of submarine and its model, which is actually a wind tunnel. Okay, so how we are going to calculate it, just take step by step. See the prototype, or you can say the submarine and its model. So what is given for prototype? The speed was given 10 meter per second. Fluid was simply seawater. Okay, kinematic viscosity is actually given in Stokes, and how Stokes can be converted to meter square per second, just multiply by 10 to the power minus 4. Okay, here it is in Stokes, just multiplied by 10 to the power minus 4. That will be your in meters per second. Density is also given 1030 kg per meter cube. So this is for your prototype. Now come to model. In particular wind tunnel model, fluid is air. Okay, the kinematic viscosity of fluid for model is 0.016 Stokes. You can convert in meter square per second as before by multiplying by 10 to the power minus 4. Okay, and also density is also given, rho m as 1.25 kg per meter cube. Now see, we have already understood what is length ratio in previous class. What is length ratio? Is simply length of prototype by length of model. So here in this particular question, LP by LM is also given as 30. The first line states that the length of submarine by model is 30:1. So here what you can get is LP by LM is simply 30. Now let the velocity of air in the model is Vm, which is not known to us right now. So for the dynamic similarity between model and submarine, the viscous resistance is to be overcome, and hence for fully submerged submarine, the Reynolds number for model and prototype should be same. Now the case again stands for the model law, that is for Reynolds number model law. Okay. Now because again the question states about the dynamic similarity, we need to conduct again a Reynolds number theorem. Now here, or model law, here again apply Reynolds number in both the situation for prototype and model. Here you can see the formula is applied, and because this particular question has given the value of viscosity in kinematic, okay, kinematic terms, or you can say in Stokes or meter square per second. So that means you can convert this nu p to kinematic viscosity by dividing by rho. Okay. So here nu p by rho, that will be equal to your kinematic viscosity. Here you can see nu p, and also this term can be converted to mu m. Now what will be the velocity? Velocity of model, that will be equal to, now can be stated in this particular expression. You put all the given terms in this expression, what you will get as Vm as 400 meter per second. Okay. Now we know what will be the velocity in model, that is 400 meter per second. Now find the ratio of drag force. Okay, because the question is asking for drag force also, the ratio of drag force also. So drag force is simply mass multiplied by acceleration. What is mass here? Rho L cube, and acceleration will be equal to velocity divided by time. The simple equation. Just put it, solve it. What you are getting, what you will be getting is the drag force must be equal to rho L square V square. Okay. Now just take the ratio of drag force in prototype and ratio of drag force in model. Just apply a ratio, simple ratio formula. Okay, what you are getting is rho p by rho m multiplied by LP by LM whole square multiplied by VP by VM whole square. Okay. Now in this question, you know what is LP. What is LP by LM is 30, and you can formulate what is VP by VM. So just put all the given values in this particular equation, solve it, and at final stage you will be getting an answer as 487.22 as your final answer for this question. So in that last question, we have used length scale ratio and also the ratio for drag force. See, sometimes when we need to sometimes any question just ask about how that particular parameter can be calculated. You can apply the units. Okay, you can apply the multiplication of particular units, and you can formulate how we are going to calculate that particular parameter. Here, because exact formula for drag force was not known to us, so we just simply applied equation for force, mass multiplied by acceleration. Okay, and what we got? Rho L square V square. Okay? So you need to remember this particular step in this particular question. Now next problem 12.19. Again that question asks for a model of spillway. Here you can see In a 1 in 40 model of a spillway, the velocity and discharge are given as 2 meter per second and 2.5 meter cube per second. Okay, velocity is given and discharge is given. Velocity is your 2 meter per second, discharge is 2.5 meter cube per second. Find the corresponding velocity and discharge in the prototype. Okay, this is actually Vm and Qm. Okay, velocity and discharge for particular model is known to you. You need to calculate it for prototype. Now, because LR is given, LR 1 in 40, okay, LR is given as 40, Vm is given, Qm is given. How this particular question where already some particular ratio is given, how you are going how you are getting the required answers? It's like this. Just assume the quantities for other prototype. Let us suppose here Vp and Qp will be your velocity and discharge in prototype. Okay, now apply other ratios. Length ratio, you know very well what is length ratio. Now apply the other ratio like velocity ratio. We know very well the velocity ratio is equal to root over LR. Here also we have used velocity ratio because we have used this particular term because we know what is LR. Okay, so Vp by Vm now that will be equal to root over 40. LR is given as 40. Now calculate again Vp because Vm is given to you as 2. Now calculate Vp as Vm multiplied by root over 40. You will get answer of 12.65 meter per second as your answer. Also, because the question was asking for discharge also, so we are going to use our discharge ratio, that is equal to LR to the power 2.5. LR is given as 40. Okay, apply 40 to the power 2.5, and also Qm is known to you, that is 2.5. Now your Qp will be equal to, you can solve, you can get 25298.2 meter cube per second as your discharge in prototype. Okay, now what our next question states, you can see the ship model of a scale 1/50, okay, is stored through a sea water at a speed of 1 meter per second. Again here you can see that 1/50, that means length ratio is given here. Okay, again LR is given as your 50. Okay, and the speed is stored through sea water at a speed of 1 meter per second. Now what again, a force of 2 Newton is required to the model. Okay, determine the speed of ship and the prototype force on the ship if prototype is subjected to wave resistance only. Okay, we know the scale ratio of length in this particular question as LR is 50. Okay, and the speed of model is also given 1 meter per second. Force required for model, okay, that means Fm is also given as 2 Newton. Okay, so these three things is known to you. Let the speed of ship as Vp and propulsive force for ship as Fp. Now, because prototype is subjected to wave resistance only for dynamic similarity, Froude number should be same for model and prototype. Hence, the velocity ratio Froude model law using equation we have. So, because we are talking about wave resistance, okay, so Froude number can be used here. Also, whenever that question, a particular question is says about the scale of length, so you can think of using Froude model law. Now here Vp by Vm, that is simply equal to root over LR. LR is given as your, or length scale ratio is given as 50. You solve it again, Vp as your root over 50 multiplied by Vm. Okay, Vm is your 1. So finally velocity in prototype will be equal to a 7.071 meter per second. Now again the question was asking for force required for prototype. You can apply the ratio of drag force as LR cube. Okay. Here Fm is given as 2. You need to calculate Fp only. So Fp will be equal to 2 multiplied by LR cube or 50 cube. So you can get an answer of 254 times 0 Newton as your final answer. Now the next question, here you can see again a model of 1:64 is given. Okay, what question states? A 1:64 model is constructed on an open channel of concrete which has Manning's n as a 0.014. Okay, find the value of n for the model. See, this is a question of open channel in which Manning's coefficient, they are asking for Manning's coefficient. Okay, so for solving this kind of question, we actually go to the open channel flow chapter where we'll find, or I am going to tell you here also, that the velocity is equal to 1 by n r to the power 2 by 3 and s naught to the power 1 by 2. Okay, so this is the velocity in open channel flow. It is actually Manning's formula. Okay, now where n is your Manning's coefficient, r is your hydraulic radius, and s naught is your slope. Okay, now in this particular question, LR is given as 64, NP is given as 0.014, and Nm will be equal to value of n for model. Okay, now we know what is r, or see in this particular equation r is taken as m, as a hydraulic mean depth in m. Okay, just you need to formulate velocity for model and velocity of prototype. Just get in ratio. Okay, what you will be getting as this equation, this particular equation in the form of hydraulic radius and slope. Okay, your slope is also have written in the form of I, but actually this is s naught only. Okay, now for dynamic similarity, Froude model law should be used. Here you can get Vp by Vm as root over Lr. Lr is given as 64. Okay, so Vp by Vm here will be your 8. Now Mp by mm will be equal to Lr. Ip by Im will be equal to 1, as Ip and Im are dimensionless. Okay, now just substitute in this particular equation what you will get as, you can find the equation for Nm, or you can get the value of Nm as, or Manning coefficient for model as 0.007. Okay, so this is for all today, and particularly all the questions in this particular chapter, types of similarity, we have gone through all the questions, almost all the questions, and you can practice another question by using different reference books like RK, Bansal, and there are other books also. So thank you. Jai Hind everyone.